Hi, welcome back to the video series. And to begin, what we're going to do in this video is explain the database that we're working with and the design and the layout, just so that you understand the data, because going forward you'll be using this data set for the rest of the videos as well. And it'll be a good idea to understand the data and what we're trying to do with it before we start troubleshooting, so that you understand the cardinality and the locking, blocking behavior, etc. So to start off with, normally we would use some kind of ready-made database, but I've seen that the ready-made databases don't really give us the kind of mistakes that people usually make, because a lot of the stuff is already handled in it. So I've gone ahead and created my own sample database, which I typically use for trainings, and I'm going to go ahead and demonstrate that particular dataset to you. This particular system contains, or this particular database contains aircraft booking information. So the idea being that if you are traveling, you'd normally go to a website and you type in the source and the destination and the date that you want to travel on, and then based on that it'll show you an available list of flights with things like the price and how many seats are available, etc. And then you go ahead and make a booking based on that. To start off with, what we have here is we've got the aircraft table. So I'm just going to show you the data in each one of these. The data is fairly straightforward. There's not really that much going on, because the intention here is to kind of just understand the data that we're working with and how that impacts uh, the queries. So you will see that every aircraft has a tail number. The tail number is usually what's identifying the aircraft itself, not the flight, but the plane itself. So you'll see that we've got the plane tail number, whether it's a jet airline or a turboprop, which is basically the difference between the one with the engine and the one with the propellers. And then we've got the seating capacity, so that as you do bookings, we'll be deducting one seat per booking. So when a plane is full, we don't want to accept any more bookings against that particular aircraft. So that's what aircraft table is about. You'll also see that we've got one guy called airports here. So in airports, what we have is the airport ID, which is a unique primary key column that we'll be using to reference a combination of the city and the state name. To keep things simple, we are assuming in this particular case that there's just one airport per city, and you'll see that the combination is basically for the US. So you'll have a city in the US, and then you'll also have a state. The next thing that we have here is something that we call a basket. Now the basket is mainly meant to store information temporarily. It's kind of like your session based information. So when you traverse through a website, typically what happens is you haven't logged in yet, you're not really doing a booking, and you're just navigating and kind of seeing the flights that are available. You don't really intend to follow through on it by doing a booking maybe. So until then, we don't want to go ahead and store a lot of that information inside the database and cause uh, 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 a lot of locking, blocking behavior with the main tables in terms of auto bookings, etc. So we're going to store temporary session level information here inside this table called basket. And as you can see, it's empty right now because I've reset the whole thing to make sure that it looks like as if this is a brand new website where so far nothing's being done. Now, when you're done with identifying the flight that you want to take, you would go ahead and then confirm the booking by making a payment, and that's when we have the bookings table where we will have a status column confirming the booking, etc. So essentially the basket table and the booking table are very similar to each other, except for the fact that when you finally do a booking, you get a reference number which confirms that your order has been placed. Then we have the carriers. The carriers are basically just the different airlines operating flights. And to kind of give random prices, what we've done is we've gone ahead and put a base price which differs based on carrier to carrier. So what we're trying to do here is kind of just make sure that everybody doesn't have the same price, and that the price of the tickets, etc., fluctuates, just to give it a more realistic feel. And so we've just given some random details there. The next thing is to simulate payments. What we've done is we don't really have a payment gateway that we can authenticate against, so we're assuming some kind of prepaid system here where the customer loads data into their account, and then when they make a booking, the amount just gets deducted from the customer accounts table, proportional to the price of the booking itself, the ticket cost. So that's what this table is about. And we've just started off by giving everybody a random equivalent amount of data, money, to start off with. Then we have the customers table, which is used to simulate the customer's booking. So we'll have details like their name, their gender, some basic information that we could use later for some additional reporting if need be. Nothing especially important happening here. The only thing that we would really be looking in terms of this particular table would be the logging in and logging out functionality, because we'd have a lot of customers who log in and log out on a website over a period of time, and after they log in, that's when we go ahead and do the booking, etc. So that's why we have the customers table. So you'll see we've got a password, and then we've got the email ID, the combination of which is what they would be using to log in. Then we have the distance chart, which is essentially just a distance chart between two airport IDs. So what we're going to do is we're going to multiply this distance by some random number to generate the price for the ticket. So the longer the flight, the more the cost, etc. And that's why we've got the origin airport ID and the destination airport ID and the average distance between the two of them, so that we have an idea about how much to charge for each ticket based on the price, based on the distance. In addition to that, we also have flight dates, which is basically just a date table that contains the dates on which flights can be booked at the moment. And as you can see, there's really nothing much going on here. It's just a series of dates. And then we have the origins. So let me just go ahead and show you that real quick. We got the origin airport ID and counts. This is something that I just created as part of a demo for something else. We won't really be using this table for anything at the moment, because it doesn't really serve the purpose of troubleshooting any performance issues. I'll come back to report dataset in a minute, but before we go ahead, there's this roster. And in roster, what happens is we get an idea about on which date which flight number is operating from which airport to which other airport, and the time that it's supposed to take off. So this is kind of the table that we would be using to identify which flights are available for any combination of source and destination. And that helps us keep track of things like, if you say that I want to fly from New York to Miami on 25th of August, you would come to this table to find out which flight numbers operate for that combination on that day. And lastly, we have the schedule, which is kind of a mapping between the roster and the tail number. So now that we know which flight number is supposed to take off, we have to assign that flight number to an actual aircraft. And here is where we go ahead and deduct the seats based on which flight that particular aircraft is operating under. So you can see that we've got the same tail number here, but it's operating under a number of different flight numbers on different dates. So the same aircraft kind of goes from New York to Miami, and then under a different flight number goes from Miami to say Houston, and then from Houston to California, and then comes all the way back to maybe New York. So at the same time, the same aeroplane would have 300 seats, or roughly about 300 seats, based on where it's originating and terminating. And that's what schedule table is about. And the last one is kind of a table that I've just created for doing reporting. So what you'll see here is I've gone ahead and created a report data set, which is just real-time online on-time performance data for every airline that took off in the US in 2013, January, February, March, and April. So we've got close to about 2 million rows here, and this is what I'll be using for some of the reporting level queries that we'll be troubleshooting later on. So now that we have looked at the tables and the data inside of it, in the next video we will explore the procedures that will be doing the DML operations as well as the select operations on these tables, and see how they conflict with each other and cause performance issues. I hope you enjoyed this video, and thank you for watching.